Welcome back, everyone, to the Connect Science webinar. It's a real pleasure to have our colleague, Rafael Rosari, here to speak on monitoring with data during the COVID-19 pandemic. Professor Rosari, I think, is known to many of you. He is a professor of biostatistics at the Harvard T.H. Chan School of Public Health, a professor of biostatistics and computational biology at Dana-Farber. He is the head of our data sciences program, chair of the Department of Data Sciences, I should say, and world-renowned for developing innovative and remarkable ways of looking at data. It's a real pleasure to have him here. I want to encourage everyone to post your questions using the Q&A tab, not the chat tab, and time permitting, we'll have the opportunity for Professor Rosari to review those. I also want to welcome people back over the next couple of weeks and months ahead, as we have a really remarkable list of speakers available at the website. You can see here, not only are all the old talks there preserved, but Celeste Simon, Fred Auld, Judith Campisi, Hans Clavers, Melody Swartz, Mike Heeman, and many, many other leaders of the world will be speaking over the next couple of weeks and months. So please do tune in. At that point, I'll stop, and Rafa, please take it away.
Thank you. Thanks for the invitation. All right, let's get going here. So there's my Twitter handle where I announce a lot of my research findings and also share data-driven results, sometimes not necessarily peer-reviewed. And then all the code for a lot of what I'm showing is in this GitHub page, along with some information about my lab. So as you just heard, I'm the chair of the Department of Data Science. We are in the Farber Cancer Institute, and we collaborate with people across the institute. So I'll take this opportunity to let you know that if you have data-driven research that needs help from some expert, please don't hesitate to contact me about that either. All right, so I'm going to start by telling you why I'm giving you a talk on COVID when my research expertise is not that. So I got contacted in late April by Nick Kristof from the New York Times asking me if I could help him calculate the excess mortality due to COVID using data made public by the CDC. And the reason he was contacting me is part of what I'm going to explain here. It relates to work I did, similar work I did for Puerto Rico after Hurricane Maria. So what I'm going to do in this talk is tell you a little bit about how that worked. I'll show you a little bit about what's in this article. What we did was we estimated the excess death based on data, and then we compared it to what was being reported and found that back in April 25th, there was we were at about 100,000 deaths, and it was about 20,000 more than what was being reported by the health departments. If you just counted COVID confirmed deaths. We did it by state as well. New York Times made this very nice graphic based on one not as nice that I sent them. And when this article came out, Eric Weiner emailed me that he saw Kristof on TV talking about our work, and he wanted to know about it. So I told him that he should wait until today when I will explain it, because it's not something I wanted to explain on an email. Okay, so this is what I'm going to talk about. I'll tell you probably for the first half hour why it was that I got contacted about this. So I'll tell you about what we did after Hurricane Maria in Puerto Rico, and then show you some of the statistical methodology work that led to that now I can use to make these calculations very quickly and make visualizations that are useful even for lay press. So then I will argue that some of these ideas of using data visualizations can also be useful now during the COVID pandemic to just know how well a jurisdiction is doing. So if we have time, I'll also tell you of some of the more recent work related to COVID in Puerto Rico as well, helping them get data out there and looking at data to decide if how the government should act. So in that regards, I'll be making an argument that just simply plotting data is sometimes or oftentimes in this case is more powerful than trying to use mathematical models to describe the dynamics of the disease when you're monitoring for decision making. So I'll also say, if we get there, I'll tell you a little bit about how we convinced Puerto Rico to use systematic data organization as opposed to basing their decisions on Microsoft Excel analyses made by hand. So I'll give you a disclaimer that I'm not an expert in this. I'm not an expert in COVID-19. I'm not an expert in infectious diseases or anything like that. As you heard, this is some of the stuff I do. I work a lot in genomics, but I'm also, throughout my career, I've been driven by applications that are not just in biology. I'm an applied statistician, and I just really like solving problems that are data driven. And in my past career, I worked on many things, including my thesis, which was in sound signals from musical instruments. And I worked on many other things, not just in genomics. So I still enjoy doing that, and that's why it was very attractive for me to help with all this stuff. So what I do as an applied statistician, something that's very important is that you always want to be understanding the context of what you're doing. It's not enough to just analyze data. You need to understand where it came from, what things mean, and what has been done in the past. So in the case of COVID data analysis, these are the people that I consult with here at Harvard. They've all been very, very nice with their time for me. So let's back to the origin story of why I got involved in estimating excess mortalities. So this is 3 years ago. This is a satellite picture of Hurricane Maria as it was going over Puerto Rico. It was a big Category 5 hurricane that destroyed a lot of the infrastructure in the island. This is a picture of the east coast of the island where it was hit the hardest. And here's a picture of the classroom where I took most of my math classes when I was doing undergrad in the University of Puerto Rico. That's now gone completely. And those pictures are just a couple of anecdotes pictures, but we were also getting a lot of anecdotes from people that live there. All my family's there, most of my friends are there. And it was dire. And we were hearing different kinds of stories that made it sound like the situation was quite bad. Now, just a few weeks, maybe 2 weeks after landfall, the President of the United States visited the island, and he was congratulating the governor of Puerto Rico for the great job that they had done. And here's a quote. You can see of that interaction, where the governor is claiming that only 16 people had died as a result of the hurricane. And if you have, for those of us had heard some of the anecdotes of what was going on, this didn't quite make sense. And it was worrisome to think that the people in charge thought that there was nothing happening, because if it was something happening, then the people with the power to fix it weren't aware. So many academics, I know many academics, journalists, got interested in trying to figure out exactly what was going on, if in fact things were they were fine according to the government or not. And from the perspective of a statistician that's worked with epidemiologists and others, the first thought that comes to mind is, well, let's look at some data, some of the data that's collected in places that have an infrastructure to do that. And it's, for those that aren't aware, this is something that in the US, Puerto Rico is part of the US, has done systematically, and is a very important thing that we do. The CDC in particular does a lot of this. This is a famous case, one of the most famous cases. We're monitoring cases of rare occurrences or unexpected or unusual occurrences led to an important discovery. This is the paper that was written by the first people that noticed a disturbing pattern in a particular type of disease, and this is eventually what led to the discovery that there was an AIDS epidemic. And when you read these, so there's a lot of this done by the CDC, this kinds of monitoring. Sometimes it's more based on a small group of doctors that see it first. Sometimes it's epidemiologists in state offices. There's many ways that they detect things, but the one thing that's always, almost always, or always the case is that you are doing a statistical analysis where you have to define what is usual and what's unusual. So anytime you read one of these papers, you'll find that they're reporting an unusual high rate of something or other. So there's always two parts of this. One is first describing what's usual. That's always done by collecting data and making calculations. And then another part is then detecting when there's something outside of what's usual. So the CDC is doing this with many things. For example, they're always surveillance of influenza and other lung diseases, and they don't necessarily look at death. They just look at hospitalizations or other outcomes just to detect outbreaks. So again, monitoring these kinds of data is something that's been done for a while. So in all of them, again, what you have to define what's unusual, and I'll be talking a little bit about the statistics behind that. That's what I'll spend maybe another 10 to 20 minutes on, and then I'll show you some results related to both Puerto Rico after Maria and then COVID. So just to give you an example of what I mean here, or just to get you on the same page of what usual and unusual means, I'll just give you an example. In September 2012, in Puerto Rico, 2,451 people died. And you can ask yourself, was that unusual? Should we be worried? What should we expect? This is 87 more than the previous year. So is that a reason for concern? So we have to define what usual is to know when we should be worried. And as you can see here, these numbers are different. It's impossible to define usual as one number. We have to use a distribution. Another example, in December 2012, 158 more people died than in September. So again, do we worry about that? Is that unusual? So just to review, on all these things, we don't define usual as a number. Instead, we define a range. This is where it becomes a statistical exercise. A distribution or a range is what defines usual, and then when you deviate from that, then it's when you get worried. So this is a normal distribution based on Septembers from the past in Puerto Rico. That has a average of 2,400, and the standard deviation is about 100. So you have year-to-year variability for many reasons that are just natural and not reason for concern. So now we can start using statistics to define what usual means, and in this case, we could say that 99% of usual years we will have between 2,150 and 2,650 deaths in September in Puerto Rico. So what about other months? Here's January compared to September, and there's a reason I'm showing you this. It'll come in later. January, more people die, not just in Puerto Rico, and pretty much I think all the Northern Hemisphere, because there's more disease, there's more viruses, for example. The flu comes in the winter, and more people die. So now a little quick epidemiology 101 side. I was showing totals because there was a lot of focus on the totals back when this was being discussed in Puerto Rico. But really, Epi 101 tells us that we should be looking at rates. And I just give a quick example here showing you that in 2011, there were many more deaths in Puerto Rico than in 2016, but the rate was higher in 2016 than in 2011 because there's less people. And another complication in all this that made the statistical analysis challenging is that Puerto Rico has a very dramatic change in demography in the last 30 years. So what you're seeing here is a histogram, a distribution of age distribution, Puerto Rico, and I have the United States just to give you an idea what's roughly normal. Starting in 1980 and all the way to 2020. And if you look closely, what you will note is that the purple is growing quite a bit, and the light blue is decreasing much more than we would expect. This is because for the last 30 years, there's been an exodus, especially starting in the mid-90s, of younger professionals from the island towards the mainland, towards the United States. So that makes it a little bit hard to compare totals, because there's more old people, there'll be more deaths. If there are less people, there'll be less deaths. So it gets a little bit complicated there too. Okay, so that's a little bit of intro, if you 101 intro. So now let's get back to the October 2017 issue. So what we wanted to do, so now that the government is saying only 16 people have died, it was to compare the current death rate to the expected death rate. So to get the current death rate, you basically go to the demographic registry, you ask them for the data, and you should be able to tell if there's more deaths than expected or not. So we will take the current death rate compared to the expected death rate. Although what everybody was doing was comparing totals. So if you want to do that, you can just multiply by the population size and compare the observed deaths to the expected death rate times the population size. So we saw 16. That's what the government was claiming, 16, and that would definitely not be outside of a usual range. So at that time, we couldn't get. Several of us asked for data to try to answer that, to try to figure out actually what was the observed death rate, but that was not being. At first, we were having a hard time finding it. Later, we actually got told that the government was not sharing that data. That came later, not in October. So what a group of Harvard decided to do, led by Carolyn Buckey, was to try to estimate the death rate in another way. Instead of getting the numbers, looking at the actual number of people who had died, we would do a survey. And we organized a survey. We sent people with tablets out into Puerto Rico. I helped them design where they should go. It was kind of an interesting logistics problem. We pick locations at random, but trying to balance urban and suburban and mountain areas. People would go there, find a household, and ask, has anybody had died here this year? And if they had, ask them what month. So that was the survey that we did. This is not what you do when you have a demographic registry, as Puerto Rico and all the states in the United States have. But because we couldn't get the data, it was the only way that we thought we could get this number. So this takes a while to do. You got to get IRB approval. You got to find who's going to do that. So it was going to take about 2 months to do this. In the meantime, there was a couple of demographers that somehow got their hands on the actual data, and they estimated 518 extra deaths in September, 567 deaths in October. Not 16. We saw that preprint on the internet, and we asked for the data it was also not shared. So but you could scrape it from the paper, and this is what it was. This is what it looked like. They had several years to compute the expected. That's in black. They had several years to compute the range. That's in gray. And then the blue points is 2017, and you can clearly see that in September, that's when the hurricane made landfall. There's this huge dump. It's definitely not 16. These are death rates, not totals. So the New York Times also came out with something in December, similar numbers, 1,000 extra deaths. And by this time, the government had upped their total to 64, which still is not outside of the usual range. The New York Times reporter did write back when we asked them how they got the data, and they explained that it took about 100 phone calls and emails to get the data for doing this. Well, at this point, we had this survey. We were wondering if it was worth doing, because now it seemed like it was done. Like, clearly the government is wrong about low numbers. Now they should be taking action to make whatever's going on improve the situation so that we don't keep having more deaths than we're usually having. But instead, this is the statement from the Secretary of the Department of Public Safety. He says there's no problem because they've seen numbers like this in December and January of previous years. Now, that you can read the whole thing, but that's basically what he's saying. And I and many others couldn't really believe that the person in charge of public health was saying such a stupid thing. This is comparing apples to oranges. If he was comparing September to January, here's September. These are the observed deaths, and this is the distribution of previous years. And here's January. So even in January, in this data we eventually got, we didn't have it at the time. The data for January was still 229 higher than the average, and that this distribution actually shrinks once you account for demographic changes. But I'll get to that a little bit later. Okay, so then by then, because of this and other factors, but in big part because of this lack of acceptance from the government, we decided to continue with the survey approach. And by January, we start getting data. So we are seeing it. It's very clear that there was more deaths than expected. And we published in May, we published a New England Journal article explaining what we had found all these findings that there was more with the survey. We also we confirmed what the previous groups have said. This is what the data looked like. This is just a survey of 10,000 people. It's a very small sample size for when you're trying to estimate something with low rates such as deaths. But even with a small sample, we were already seeing it. This is the actual data. It's not like a big number. It's 10,000. These are the actual deaths. This is the ages of the people we were told had died and the months. I'm not showing you after the hurricane yet. I'm showing you also the ages, so you can see this. It's as expected. It's mostly older people that had died in these households in that year. Now I'm going to show you the results of the survey for after the hurricane, and we see many more deaths reported and also many more younger people reported. And then the other thing that we find when we do this is that we find it seems like one of the main reasons, or the main reasons why these people were dying was not because they were struck by a tree or taken by a river. It was because they didn't have access to medical care. So this paper actually got media attention. The number that we reported, which was not really the main part of the paper, but the estimate of excess deaths that we reported, which is much bigger than the governor's, got a lot of attention. And eventually, one of these, among the many news articles and interviews and media exposure that the paper got, the one that really stayed with me was this interview from Cooper Anderson, when he's asking the governor not so much about the fact that he was insisting on the 64, but asking him why he didn't share the data with us, because that's what we were, when our study gets criticized for being a survey, which of course it's not, as I said, it's not really what you do when you have a demographic registry. Our answer was, well, we would have done it with the registry had they given us the data, but they didn't. So that's what Anderson Cooper decides to grill the governor on, and he says this. He says that the data is available and they'll be held to pay if it's not. So the next day, they actually make the data public. So now we have it. Now when we send the emails, we get the data immediately. And I'm going to show you how obvious it is that something was going on. Now we have all this. Now we have daily data. We had more than we asked for. We got daily. Actually, we got every record de-identified, so we can compute daily deaths by age. It's a very complete data set. Here's the daily count of deaths in Puerto Rico in 2015. You can see that there's more deaths in January. That pattern is very, very common. That line, that curve you see is just a smoother going through the data. This is 2016. Again, you see the same pattern of higher values on the edges in the winter. Here's the first 9 months of 2017 in purple. Again, looks just like all the other years. And now I'm going to show you the data from after the hurricane. And you really don't even need any sophisticated statistical analysis here. It's pretty obvious that there was something going on. The government had this data. They should have seen it and done something about it. So that's when we get this data. We show it, and the government. This is that's another part of the story, is that the government had hired a university to do a study for them. They had not come out with it yet, but then in August, this is more than a year after, they finally put out the report, and they say it's 3,000 extra deaths, around, plus or minus, and that's roughly with the same number that we got once we analyzed this data. So from this work, I started with a student, Rolando Acosta. We started working on statistical methods for analyzing this data, because it was a little bit more complicated than usual because of the changing demographics, the fact that there's a direct and indirect effects. So I'm going to show you a little bit of the statistical innovation here that we've done, and then I'll show you the model applied to COVID data. So this is what the CDC does to call excess deaths. They do it for weekly data, and they use previous years to compute an expected value for each week. They use previous data to compute a standard deviation, not standard error. This is what it should be. So to get an idea what the usual range is, and then they say anything above expected plus 2 standard deviations is not usual, and we're going to call it an excess death. And we're going to call that week an excess death week. So that's what they do. Now there's a little problem with that approach. So here's the Puerto Rico data, and I'm showing you the CDC's approach. So you're going to see this curve is the expected based on previous years, and then this orange line is the expected plus 2 standard deviations computed the previous year. And here's the hurricane made landfall in September, so around here. So yeah, you see these values way up there. The little cross means excess death. Now the problem is, if you look closely, the mouse is being annoying. If you look closely, look at all these points after the hurricane. They're all above the average. So this is the average from previous years. Look at how many points are above the average. All the way up to here. Not one time does it cross. But the CDC doesn't really see that, because they kind of have to see an extreme case for each week to call it an excess death. So what we did was we used a statistical model that first does daily data instead of weekly. And it uses a statistical technique called smoothing in the context of now I'm getting a little bit more technical, a generalized linear model. So we assume that it's a Poisson count. This is the expected count, mu t, for those that can follow equations. Otherwise, don't worry, I'll tell you what they mean. This is the excess in percent, how much more. So if it's 0, if f of t is 0, it's a normal year, it's just mu t. And then there's some error here, not really error, but just natural variation from year to year that explains the fact that you can see deviations just because of normal reasons. And then the mu t, this is the expected. One of the things our model did that was helpful is that it broke it down to a seasonal pattern, a overall trend, because medicine's getting better, so death rates are going slowly down with time, and then a weekly effect, which was something we weren't expecting, but it makes sense now for certain demographics. Puerto Rico, especially the younger demographics, there's a lot more deaths in the weekend than in the week. And then more importantly, this is the population size, which we also try to estimate in different ways because of the population displacement that happens after the hurricane. So once you do that, we get a different story. Now our estimate of F is how much you're deviating from what's normal. This blue line is F, is our estimate of F, and you can see that the blue line is above with a standard error, because we have a statistical model, we can get standard errors too. Our expectation is this dotted line. I mean, I left the CDC ones in there. This dashed line is our expectation. You can see that for a long period, all the way up to March, there was excess deaths in Puerto Rico. So there's a comparison. We find a very long period of about over 5 months where there was more deaths than usual. So that's what we found. We compared it to other hurricanes, and the only one in the US that compares to Maria is Katrina. Katrina had a big spike the first day. There was about 600 plus deaths on the day the levees broke. That's why there's a jump here. This is excess death accumulated. Sorry, I didn't say that. So this is excess deaths as the days after the hurricanes go. So you can see that there's a big jump in Katrina, and then it continues to be increased, but not as fast. With Maria, it goes way up to 3,000. And another thing we found when we got this data set that went back to the 80s is that in 98, Puerto Rico had a hurricane. It wasn't even known to be that bad. That was comparable to Katrina. And now this has us thinking that there's a serious infrastructure problem in Puerto Rico, where as soon as something like a natural disaster happens, as opposed to something like Katrina where you have a big jump at first, it's just this sustained indirect effect, probably mainly due to the lack of a reliable power grid. Hugo is a hurricane from the 80s. I was there for that one. That didn't have much of an effect. Okay, so that's what we did, and now the work we did with this is what led Christoph to contact us for COVID, and now we have all the software ready. So he was very impressed of how quickly we could do it, but now it's our package, so it's pretty, it's not that hard for us to run these on new data. So we've done it for other countries during COVID, which aren't really reporting cases very well, some of them, and there's a couple of striking cases like that we hadn't heard of as much. Like we have heard of Spain. There was a big jump in Spain. And again, this is not COVID deaths. These are excess deaths computed from just pure mortality numbers. We don't know for sure if these are due to COVID, although we suspect that's what's causing it to go up. So we can see later came first is this huge one in Ecuador. This is a % increase. So 300% increase is a lot for a country. And then we see Chile, Peru, and Ecuador Peru and Chile having later increases. It's not starting in March, but later in April, May. Here are U.S. states. So you see New York City was hit the hardest, 600% increase at the worst point. So you can see this is about March. You have New Jersey was hit too. Notice the scales are different. I just want you to be able to see the bumps. So keep looking at the % here to compare. So this is 3 times less, but still striking. New Jersey, New York without New York City. There's us, Massachusetts, big change, 120, pretty bad. So you have all these other states, and the other thing I want to call your attention to is places like Arizona and Mississippi. In the South in 2018, there was a bad flu season, and you can see it there. You see that little bump? See that there? You can see it in New York too, a little bit right there. It was only in certain places. So these are all the March, April bumps that you can see. And remember, again, this is not COVID. This is just excess death, just based on death data. Here are the recent ones. These are now starting later in June. So Arizona, California, Texas, and Florida didn't really have a big surge in March, but they especially Arizona is having had one. It's now coming down. That's good. Had one in June and July. Here again, you can see the flu, the 2018 flu right here. There it is. It's in all these states. You can see it pretty clearly. So here's a comparison of 2018 COVID compared to the flu. So just basically they show how much worse COVID was in the majority of states, especially where it was really bad, like New York, New Jersey, Massachusetts. This is the city, this is the state. But there are some states where it is true that the flu was as bad as COVID. The problem is that for the states that really got hit, they really did get hit very, very hard and much worse than the 2018 flu. Okay, so now to tell you a little bit about what's been happening recently with COVID-19 in Puerto Rico, and again, my work on Hurricane Maria leads people to contact me, reporters, for example, and then when I answer their questions, I start getting data and getting involved in it. So I'll tell you a little bit about this. I'll finish my talk with how we've been helping Puerto Rico monitor the COVID-19 pandemic, basically with data visualization. So I'll just do it chronologically. So this is in March 11. I was very concerned about Puerto Rico because of two things. One, the age distribution, as I showed you earlier, it's a much older population. This is the age distribution in Puerto Rico. This is not normal. If you haven't seen a typical age distribution, there's way less old people in most countries than here. You don't see this bimodality of very young and older with very few working age people. So you had that combined with the fact that from China, from the China data, we could already see that it was older individuals that were affected by this disease. So that combination made us very worried about PR. But also what we had seen in Maria of how the government wasn't really, taking action or trying to monitor the situation, that we could see something like what happened in Maria happen again. However, 4 days after I tweeted that, the government, I'm not saying this is why, but it was nice to hear that the Puerto Rico governor went into lockdown. It was the first state jurisdiction that did it. So at least that was a good sign. They closed down on March 15. Now, this is an article that comes out in March 25th. So this is 10 days after the lockdown. And this is a article claiming, well, not claiming, they had somebody run one of these mathematical models on the data that they had, and they were predicting that between 16,000 and 58,000 were going to die in Puerto Rico in the next few months. Now, Puerto Rico has 3 million people, so 58,000 is 2% of the population. So this article is saying that it's possible that 2% of the population is going to die in the next few months. So this is, of course, very concerning to see an article like this, and I got contacted about my opinion about it, and my main answer was to basically, this doesn't. No, it's supposed to be a movie. It's not really working. So I'll just tell you what the movie does. Oh yeah, it's not going to work. All right. So this is a, let's see if it's, nah. So basically this movie just shows you how much the estimates of, if you base it on data, how much the estimates of excess of deaths or cases is going to change. Just based on model, not model specification, just based on the variability of your estimates. This red line is the estimate of the black line, and if I play the movie, you're going to see the red line just moving all over the place as you start collecting data through the days. So basically, it's at that time there was so few cases, we had so little information that it was basically impossible for me, at least, to confirm that report. And that's when I started getting contacted for help on what to do by a organization that's a science trust there. And what I was pushing was just get data and show it. That's what they were doing in Massachusetts. They were computing something called a positivity rate, as well as cases per capita and hospitalizations, just the basic numbers, and showing them daily and looking for patterns. Now, to do that, you actually need to get the data, and that was a little bit challenging again. So the one thing I wanted to do for Puerto Rico was help them be able to compute the positivity rate, which is the number of positive tests divided by the number of total tests per day, and use that along other things like hospitalizations, ICU usage, to monitor the situation. So at that time, the only data you could get were number of deaths and cases. So they were reporting cases. Here's an example of a screenshot I took at some point in July 10th of cases. You can see there's a little bit of a uptick at that point. You can also see there's not that many cases. And the problem is that we don't know if this is due to more tests or not. So there was no access, at least at that time. I couldn't find a way to get access to the test. And you can also see here in this plot, you can already see it. If you look closely, you see there's this up and down pattern. That's, of course, there's a weekend effect. If you compute the average number of cases per day of the week, you see a very strong day of the weekend effect, which is, and my understanding of why this is so strong is because the labs, the clinical labs get their reagents on Monday, and then as they start running out, they start controlling the number of tests they do. It could also just be that people aren't work. There's not as many people working in the weekends. So here's just to show you the importance of taking the test into account, the number of tests. This is the number of cases in the U.S. per day, and this makes it seem like August was way worse than March, which just doesn't make, it doesn't coincide with what we see in terms of deaths and hospitalization, and that's because the number of tests have gone up. This is the number of tests in the U.S. So if you compute the positivity rate, it tells a much different story. It's still concerning that it started going up again in July, and that's mainly driven by what happened in Texas, Florida, Arizona, and California, but it isn't as bad as it was in April. That's just not the case. So positivity rate is I think the best way to monitor this, at least when the number of tests is changing so dramatically. So at that time, just to give you an idea of how bad the data in Puerto Rico was, this is the JHU dashboard for COVID, and if you just went and clicked, show me the positivity rate by state, you get that Puerto Rico had 100% positivity rate, which obviously can't be right. And again, these places are just scraping data from the states, and they're not computing anything themselves. They're just telling you what the states are telling them. Here's another graph for Puerto Rico showing the positivity rate jumping from 0 to 100. So you're going up and down like that. Again, clearly the data wasn't useful as it was. So at that point, the first way we can compute positivity rate was with the Science Trust. Sorry, this is in Spanish, but I'll tell you what it's saying. With the Science Trust, not with the government, we're able to get access to the data from the clinical labs. They're private labs that do 90-some% of the tests in Puerto Rico. They're sharing their weekly totals, and they would share the data with me, and now we can actually compute. So the blue is Puerto Rico, the positivity rate, and it does look, at least in June, it looks like things were actually doing very well. Perhaps because of this lockdown and the fact that it's an island, and who knows what other factors. Now, if you look closely at this, I remember when I first made this, I was happy to see how low the positivity rate was, but You see how it has a little bit of a tick there? So, you know, just be cautious is what I was thinking. So at the same time, around that time, this is at beginning of July, a little bit before that, July 1st, Florida starts taking off in their cases, and Florida has 27 direct flights to Puerto Rico every day. So that was reason to concern. Now we get the data again from these private labs, and we see that that uptick I showed you earlier continues. Now we go up from about 1 to above 2, still very low, but the trend, and here is one of the reasons I think why I think data visualization is so powerful, is you don't really have to make much of a calculation here. You just see that there's a trend, and it's not that you're making a conclusion, but at least you're getting a sense for what's happening. So at that time, the government finally decides to work with us, and they give me access to an API that grants me, and eventually everybody, direct access to their database, which is great. I mean, that's not, I don't even know if they have that in Massachusetts. This is a big advance. They have these people working in their informatics division that are very competent. I just needed to talk to them to explain what we wanted, and they make available an API. And now I can, with just a couple of lines of codes, I can make this plot. Seriously, it's only like 5 lines of code that I need to plot this. Not the blue line, that takes a little more, but the little dots, which is the positivity rate by day, is very easy to do. So now that finally they shared it, it was timely, because as they shared it and we start preparing graphs for them, the positivity rate goes above 5, which is kind of a red flag once that happens. And that we build a dashboard for them in like a couple of days. It's, again, once you have the API for the data, all this other stuff is not hard. You can see, if you want to see all the code and the dashboard. Actually, I'll show you the dashboard. Let me see what happens if I click on this. I have to share. I have to reshare real quick. Here it is. So this is what the dashboard looks like. This is the graph. It updates every day. And then it has other things. It has hospitalizations, ICU, deaths. You can change the dates. It has a little map, and you can change the dates that you look at. This is the last 2 weeks. It gets much redder. That's the positivity rate by town. So what we built that for them in a couple of actually like a few hours. Actually, once you have the data, building these things isn't that difficult. So let's get back to the presentation. So then I think it was a few days after we made that dashboard, I get an email from my family saying, "Hey, your plot's in the governor's press conference." So they took a screenshot of it or something, and there it is. This is the governor's press conference, and there's the plot that we had made for them, and they actually reinstated parts of the lockdown after we helped them see all this data. So that was I think that was a good outcome. They're still looking at these things. They're making decisions more based on data. I don't know if completely, but at least they can see it. They can look at that and decide. So just the important thing I hope that they take away from this is that once you organize the data systematically and you stop like emailing Excel files, building tools is actually cheap. I didn't charge them anything for this. I know they hire software companies to pay them $100,000 to build them dashboards. This took me a few hours, and I actually kind of have fun doing it. So the moral of the story is make your data available, easy to access, and the people, academics and other journalists will build tools that are useful and you might find useful. So monitor the data visualizations. One of the things we don't do in ours is we don't compute any of these more complicated summaries like the R, the reproduction value, and all these other things that you need to fit epidemiological models. I don't see a need for that really if you're making decisions day by day. the positivity rate of ICU usage and cases per day, that kind of tells you all you need to know, just seeing patterns that things are getting better or worse. And another thing we learned is that doing it by geographical region, I really didn't show much about this, but we do see by looking at the cases or the positivity rate by region, we can almost see how the outbreaks start. Like you see this one town gets red, and then the towns around it get redder, and then the whole thing gets red. So I think it's also important to be very as granular as possible when it comes to geography. All right, so I'll stop there. I'll thank Nicholas Christoph for contacting me and getting me started on this, and Eric Weiner, who asked me to explain this to him. And here it is, Eric. I hope you're watching. You can watch it later if not. And then all the people that helped me with access to the data and some of the coding, some of the questions about COVID. And of course, always thank you to the taxpayers that pay for my time. Thank you.
Robert, that was just fantastic. So timely, so interesting. I was wondering if you could help us understand how you think about excess deaths, related deaths, and specific cause mortality, whether you have any access to that kind of data, because that's obviously going to be very helpful for governments and public health officials to actually target interventions.
Yeah, absolutely. Yeah, no, you can get all that. So you can get cause of death, and in the case of Puerto Rico, we get records basically. We get like every line is a person that died, and it includes the cause of death. And we do look at things like that. Like at the beginning, we were monitoring the respiratory deaths just to see if there was upticks in that. So let me answer your question part by part. So I think now I'm thinking about, in theory, what I would like to see, and it's actually very implementable. Excess death gives you a crude, quick way of monitoring the situation in a way that you really don't need much information. And it's not ambiguous, right? Someone dies, there's really not ambiguity in that. And you can get that data pretty much real time. As soon as a hospital or the retirement home or wherever it is where it happens, you could say pass a law where this has to immediately go into a database. So then we can monitor in pretty much real time excess deaths, and I think it would be quite useful, especially in places where, say, like they take too long in implementing testing for an infectious disease. Slightly more advanced would be to just do hospitalizations based on a specific type of condition that you think is concerning. Same thing, as long as it's done quickly, you can make plots and see patterns. Now, with that said, a slower analysis that's also very important is then to look for other covariates that explain worse or better cases. So one of the things I didn't show here, I could have easily shown it. It was that we had a data from Cook County. The Cook County coroner was putting up their data daily, and we very quickly saw that the race differences, the black versus white versus Hispanic. Especially in Cook County, it's more black versus white because the other populations aren't as big, and it was very clear that there was a disparity. And again, that was just like not much information in the data except the fact that the person died, and then we knew their race. Now, to get to the second part of your question about getting to the causes, yeah, that information is there, and you can do analyses based on the different covariates that you care about. That part does take longer, and I think that's okay, because that processing that information, for example, cause of death, it's not something you can always do right away. So I know that the CDC data is about 45 days late, because they have to they want to make sure that they get the cause of death right, and they have all this information they want to put in the record before they actually make it official. So yes, we can do that. It's important, and we can actually do it now. But I would like to see a dual approach where you have the quick death information and other hospitalization, whatever else, and then the more informed analysis that happens, I don't know, 45 days later or whatever it is that it takes to get this information right. Now that's just excess death. Now, how do we distinguish it from COVID related? So one argument I would make is that in March, when you're seeing the excess death go up, like in New York, 600%, what else could it be other than COVID? Was the other thing you could argue is that it's, I mean, there may be other things, but the other thing you could argue is lack of access to healthcare. So people are on lockdown, they don't want to go to the doctor, and then they have a heart attack when they really could have avoided it had they gone to the clinic. It's possible that's happening, and that's adding to the excess deaths. So that's a possibility for why we see more than we see. But at the end of the day, I mean, I would still call that a COVID-related death, even if it wasn't actually COVID. But yes, you're right that once you have the information of what the person died of, then you can break it down that way. Hope that answers your question.
Absolutely. So the next question is, CDC guidance is changing around testing, and I don't know if you saw the piece by Harold Varmus in the New York Times. And so there may be geographic variability in whether contacts are being tested. So how do you think about that? Presumably that could actually lead to somewhat false increases in test positivity because only sick people are getting tested and so on. So
absolutely.
How do you analyze that kind of data?
That's right. That's tough. That's a tricky one. When you change who you test, and your positivity rate changes. Now, I'm going to say one thing I've learned through this process, because when we were trying to help Puerto Rico, we're trying to learn as much as possible from other places. The CDC makes recommendations. I don't think the states are going to listen. The states have, like, especially in Massachusetts, they have this kind of down. They know what they're doing. They have a database. I don't think they're going to change anything. Now, I don't know about other states. Maybe some other states that are more influenced by the administration might change, but I don't know. I don't necessarily think they will. The health departments in states don't seem to be, as at least what I've seen, they don't seem to be that political. Like the people that work there, they're not. It's not like they get named by the current governor or anything. They just work there. That's their job. They're career scientists or epidemiologists. I don't necessarily see them changing the way they do things. So I hope I'm right about that, because it's important that they don't. It's important that states continue doing what they're doing and ignore whatever confusion is coming out of the CDC right now.
I think we can all agree with that. I'm curious, one last question. The data that you published in the New England Journal based on the survey, have you had a chance to go back to that data now that you have more granular actual data or that analysis, and see the extent to which it was, correct or?
Yeah, absolutely. I think a lot about that. That was done. We wanted to get that paper out before hurricane season, so we did as quick analysis as we could, which was hard for me being a statistician and wanting to do everything super correctly. But I think that was the right decision, that we did it quick, because it did shake things up and made the government act. Now, to answer your question, I knew this already because it comes out of the math. The precision of a survey like that is terrible. I mean, our confidence interval, the range was almost 8,000. Right? It's a huge range because it's a limitation of the survey. So one thing we could definitely have done better would have been a much larger sample size. But again, I knew that we didn't have the money to do a larger one. We got like 50K from the School of Public Health, and that was it. So yeah, a larger study would have been better. The other thing that we could have done better, I think, was think a little bit more carefully about adjusting for the age, for the demographics. I think we ended up having a slightly older group in our survey, and we had that calculation in the supplemental material, but maybe that should have been more on the upfront. That would have given us a closer number to what ended up being what we found once we had the demographic data. But with all that said, all the current estimates fall in our confidence interval. So, you know, I think I'm not you know, I think it was a good study, and it had a good consequence. Yeah, but maybe it might be worth writing up some lessons learned. The other lesson I learned, but this is not science, this is communication, was that as much as I tried, there was a confidence interval, and it was very important to me. I remember talking to the press, to the PR people, that they had to give the confidence interval every single time. They didn't come through. And all the I remember telling them, listen, the last thing we want is an article with the title, Harvard professor says 4,000 people died in Puerto Rico. And that was like exactly what all the headlines were.
Oh, it's even worse. It's Harvard professor says 4,237 people
Well,
died.
like it's or more. There was some that would say, like, I think Hillary Clinton said more than 4,000. And so, yeah, that one I don't know how to deal with. I mean, how do you, because as much as I try to keep it like, keep the statements like statistically accurate, it just, I don't know what else I could have done. I mean, one thing I did learn maybe that I could do differently in the future, not just me, others, is not use, when you report the confidence interval, don't use numbers that take into account the precision you have. So don't, like you just said, like the exact number, 4564, 4645, 4645. That's the actual number. There's like hats with it now. If you go to Puerto Rico, and you'll see it like in graffiti and stuff like that. If we had just said like 4,000, then it doesn't look like we actually counted people. You see, so because if our precision was in the thousands, then all those digits don't mean anything. You could also, some people told me you just should have said more than 800 or something like that. Now, I mean, those are all good points, and something I'm currently thinking about this. What are the best ways to communicate this kind of finding?
Yeah, I would personally love to see a follow-up piece in the New England Journal, whether an editorial or otherwise, written with the journal editors or not, that just talks about, you know, how to get things as close to right and as quick as possible under these circumstances. You laid it out really clearly. If you had waited another week to publish to try to get a little bit better, it would have been another week before the governor said there was hell to pay if the data is not available. So
yeah, right.
There's a clear trade-off there.
Yeah.
All right, we should wrap up. Again, that was really wonderful. I noticed almost everybody stayed on for the additional discussion because I think we're just pining for answers in this space. I want to invite everybody back on Thursday for Celeste Simon at noon. And until then, everyone, please be well. Thanks again, Robin.
All right. Thank you. Thanks for inviting me. Bye, everybody.